Two monomer of maltose. Maltose on hydrolysis gives 2 moles of D-glucose present in C. The functional group present in maltose is, what are the functional group present in maltose? Maltose is the structure of glucose. Its a structure containing at one chiral center acetal and another one is hemiacetal. So it has one acetal group and one hemiacetal group present in D option. Which of the following statement is not true for glucose? Glucose exists in two crystalline form, both alpha and beta. In cyclic form, they existed as alpha beta, both are anomers. Glucose gives Skiff's test for aldehyde. Cyclic structure cannot give Skiff's test. It is a wrong statement. Option B. Glucose with alcohol in HCl condition gives acetal. In that acetal, one of the alcoholic group is bonded to methoxy group, converted to methoxy group. So in that one hydroxy group is converted to methoxy group, then only four hydroxy groups are presented. It gives tetraacetate. In first four is presented. Glucose with Ni and H2 gives sorbitol. It has one excess hydroxy, so it has a total of six hydroxy groups with N-hydride gives hexaacetyl derivative. Next option is 6. Glucose with equivalent of acetic anhydride gives acetyl halide. Generally, glucose containing 5 hydroxy groups, it gives pentaacetyl derivative present in B. The number of chiral carbons present in sucrose. In sucrose, glucose is a cyclic form. In that glucose, it has 5 chiral center. Similarly, it is a cyclic structure of fructose. In fructose, there is a 4 chiral center. Total 5 plus 4, 9 chiral centers are presented. Amylopectin compound is a branched isomer of alpha-D-glucose having glycoside linkage at C1 and C4 and C1 and C6 present in A. Fructose and glucose can be separated by fructose having a ketonic functional group, glucose having aldehydic functional group. These are separated by the Selivanov reagent. Fructose gives fast taste. Glucose and galactose are identical configuration at all the position except fourth carbon. They have remaining all configurations are same, hence they are C4 apimers. Maltose on treatment with HCl. Maltose on treatment with HCl gives a glucose. Maltose on hydrolysis gives 2 moles of glucose formulas. Which of the following statement is not true? On hydrolysis for produces glucose and fructose. Sucrose on hydrolysis gives glucose and fructose. True statement. The glycoside linkage present between C1 of glucose and C1 of beta fructose. It is wrong statement. For beta fructose, the glycoside linkage at C2 carbon. Number of stereogenic centers. Number of stereogenic center in linear structure and cyclic structure. In linear structure, there are 4 stereogenic center. In cyclic structure, 5. 4 and 5 is present in A. In the following sequence reaction, major product Q is, initially it is a glucose with HI glucose gives N-hexane. N-hexane with chromic oxide gives a aromatization, hence hexane converted to benzene ring. and that benzene react with the Cl2 light, it is involved in addition reaction gives benzene hexachloride. In benzene hexachloride, there is no unsaturation and it is benzene hexachloride present in D. A disaccharide cannot oxidized by bromine water. It indicates there is no aldehydic group in that disaccharide. The acid hydrolysis of X leads to levorotatory. Levorotatory given by the sucrose. So in option A, sucrose is presented. It is alpha D glucose and beta D fructose, both having glycoside linkage at glucose first carbon and for fructose at second carbon present in option A. Treatment of D-glucose with NaOH. With D-glucose NaOH, they are converting to mannose at C1 carbon. Configuration is reverse. And they also converted to ketonic group after tautomerism. Hence, glucose with KOH gives fructose and mannose. The fructose and mannose structures are present in option C. It is a glucose at this chiral center. If it is ketone, fructose at that chiral center is opposite mannose present in C. The two form of D-glucopyranose are called alpha D-glucose and beta D-glucose are pyranose structures. They are different in C1 carbon, hence named as anomer. Anomers of the compound at different in configuration at C1 carbon. Which of the following gives positive test with tolerance? Hence, it is a reducing sugar. Here in option A, sucrose non-reducing and D also sucrose non-reducing. Acetophenone, it is a ketonic function group non-reducing. Hence, option B is correct one. Glucose and fructose are reducing sugar. They can give positive test with tolerance reagent. The given compound is a D-glucose with HNO3. It gives a saccharic acid and it has a plus 52.7 degrees rotation and produces a degree of rotation having minus 52. Minus 52 indicates it is having a opposite form of the, if it is a dextrorotatory, it must be a levorotatory compound. These structures are present in C and D. C and D is the correct option. Which of the following statements are true? Two six-membered ring cyclic hemiacetal of D-glucose are called anomers. True statement. Hydrolysis of sucrose gives dextrorotatory glucose and levorotatory fructose. True statement. Monosaccharide cannot be hydrolyzed. It is also true. Oxidation of glucose with bromine water, glutamic, not glutamic, that is a glutaric acid. So D is wrong one. For invert sugar is a sucrose. The invert sugar is prepared by the maltose. Wrong statement. Invert sugar is an equimolar of D-glucose and D-fructose. True statement. And its specific rotation is minus 20. Hence, B and C is the correct option. The correct statement for the ninth question. In ninth question, the X is the compound of sucrose like structure. It has a free OH group at this position and here it is the second carbon. In second carbon it is a ketol form and it is a glucose also having at C1 carbon acetal form. X has both acetal structures and same with y is the compound having acetal structure and it is the C2 carbon. It is a acetal hemiacetal structure. The correct statement for this question is X is a reducing sugar. In X, there is no free OH group at second carbon. In both second carbon, there is no free OH. It is a non-reducing sugar, and it is the wrong statement. X is a non-reducing sugar, and Y is a reducing sugar. It is the true statement B. So, due to free OH group at second carbon, it is a reducing sugar and there is no free OH group. The glycoside linkage at X and Y are alpha and beta respectively. It is an alpha beta form because OH group is present on top side. It is an alpha form. OH group present on downward the direction. So B and C correct. Glucose gives reddish brown precipitate with the phalanx. Glucose is a reducing sugar. It can give coloration with a phalanx solution. The reaction of glucose phalanx solution gives CuO. It is a cupric, but it is a Cu2O. That is a cuprous compound. It is the wrong statement. It cannot Cu, it is Cu2O. Statement 1 is true, statement 2 is wrong. The total number of stereoisomer for this pyranose, this compound having a 1, 2, 3 chiral center and 2 power 3, it gives total 8 isomers. Which of the following disaccharide not reduces tolerance? For that not reducing tolerance at second carbon free OH is present, it can reduces. It is the second carbon, there is no free OH group and it is acetal structure, and it is the second carbon, it has a free OH group, it is a hemiacetal structure, it can reduces. And in Q there is a second carbon acetal formation, and it is for the second carbon for next ring no free OH, it is also a acetal form, hence Q is a non-reducing. So P is a reducing sugar, Q is not reducing sugar. The structure of D glucose is the given one. Draw the L structure. L structure is its mirror image. In that mirror image, all the right-handed compounds are present in left side. So these compounds originally it is a left-hand side. In its mirror image, they comes under right-hand side. So it is the hydrogen. Here are OH group. Here is H group, and here is H. To the H opposite OH, OH opposite H, and it is the its structure. So when the given reaction of L glucose with tolens, the aldehydic group is converting to carboxylic acid and remaining structure is as it is presented.